Hello. So in previous lecture, we found that if at all your total charge is zero, uh, if a total charge is zero and origin is symmetric with respect to the or charge is symmetric with respect to origin, uh, then and if charges in the last lecture we've done that if your total charge is zero and if your charge distribution is symmetric with respect to origin, or you can say that if your origin is a point of symmetry, then the total dipole moment would be zero and total monopole moment would be zero. And in that particular case, the leading term would be quadrupole moment. Okay. So these two things are to be remembered. That the first point I'm writing here is that if the total charge is zero, then P vector would be leading term provided P vector is non-zero. Also, if total charge is zero, then we've derived in initial in our the derivation part, we derived that if your total charge is zero from this long derivation on multipole expansions, and then obviously on this thing, this is the Griffith's approach. So Griffith has done it in an easier fashion. So anyway, the idea can be conceived that if your total charge is zero, then the dipole moment, that is P vector, becomes independent of origin. Becomes independent of origin. Okay. And second, if both dipole, if total charge is also zero and if your P vector is also zero, null vector, then obviously your quadrupole moment would become independent of origin. Then your quadrupole moment would become independent of origin. And shortly we are going to see that this quadrupole moment happens to be a tensor. Okay. So in generalized way. So today I took a linear array of charges. So if I take a linear array of charges, then things are quite simple. But if I want to complicate the things up, and really things can get complicated as if I take it in a more generalized fashion. So in more generalized fashion, the quadrupole moment would then turn out to be a tensor. Okay, so that we'll see later on. But right now we're concentrating on developing these basics. Right now we are concentrating developing these basics. So obviously this is quite difficult as such, but I hope would become independent of origin. Okay, and thirdly, another thing that I wanted to assure you, like assert right now, was that if there is a point of symmetry, if there is a point of symmetry, or you can say that if the origin is the point of symmetry, or you can say that if symmetry in the sense of distribution of charge. So if with respect to the origin, your charges are distributed symmetrically, then the net dipole moment happens to be zero. So in these 3 points are something that is the gist of the lecture that we did in last 1.5 hours. So let us move forward and see how questions are asked in the examination, how you're tested. So let us begin with a few of the ideas, and all these are questions of the examination only, which I have put as ideas, right? Okay. So I hope it is clear. Alpa, is that clear? Okay, good enough. So so let us take one of an idea from ISC's PhD's question, and I will just write for you. So for example, a spherically symmetric charge distribution. So the charge distribution is spherically symmetric. So a spherically symmetric charge distribution, rho r, has a net charge zero, zero. Okay, net charge zero for an arbitrarily arbitrarily, chosen coordinate system, the dipole moment will also be zero. Why dipole moment will also be zero? Because C will also be zero. Why it would be zero? Because see, the net charge is zero. If net charge is zero, the dipole moment would become independent of origin. So dipole moment will become independent of origin. And it all so let us take for convenience, let us take a spherically symmetric, let us take a spherical coordinate system. It is already saying that your charge is distributed spherically symmetric. Okay, spherically symmetric means it is invariant with respect to. Okay, so whatever charge you can find here, exactly opposite, diametrically opposite, the same charge will be there. So overall, you can expect what? Overall, you can expect that because of the symmetric distribution of charge, as I mentioned, the net dipole moment would be zero. Because whenever there is a symmetry, whenever the origin acts as a symmetry for the distribution of the charges, the net dipole moment becomes zero. This is something that we have derived. Since net dipole moment is zero, because net charge is also zero. So net charge is zero. So your dipole moment becomes independent of origin. Why not take origin as a center of our coordinate system? And if I take so, and if I want to now I know that my rho as a function of r is spherically symmetric. Is spherically symmetric and spherically symmetric. Okay, so spherically symmetric means it is invariant with respect to the translation pi and minus pi. So for example, if I go to theta and if I go to pi minus theta, so like the charges would be like they would be same. So with respect to origin, you can see that your charges are symmetrically placed. Let's say this is dq here, so there would be dq here as well. So since the charges are symmetrically placed with respect to origin, so your net dipole moment would be zero. And if your net dipole moment is zero, so the leading term would be 1 with quadruple. So I'll not say anything about quadruple moment right now, but I would say that your net dipole moment will also be zero, and your net charges would also be zero. And also that I can say that the dipole moment would be independent of origin. Is that clear? Is that clear or not clear? Okay, good enough. So this particular question, or I could say fact, was asked in ISC examination. So initially ISC had a different PhD entrance. So this was asked there. Okay. Another question that was asked in GATE exam. This particular thing was asked in GATE exam. I'm just giving you an idea. It was said that charge minus Q was uniformly distributed on the sphere. Was uniformly distributed on the sphere. So charge minus Q was uniformly distributed on the sphere, and Q was placed at the origin. Q was placed on the origin itself. So Q was placed on the origin itself. Then also you would say that your net dipole moment would be zero. Why net dipole moment would be zero? Because you see your total charges are zero. Your total charges are zero. So what you can say, your total charge is zero. So first thing is that your total charge is zero. And if your total charge is zero, that implies your dipole moment would be independent of origin. This is something that we have derived. Also, you can see that if this is constituted by small charges dq, 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 and since each of them would have a value of what? Let's say this is your A. So each of these dq I can write as q upon 4 pi, and let's say this distance is A, dq upon 4 pi A square. So with respect to origin, if you see this charge dq there would be another charge dq symmetrically placed on the or should I say not diametrically opposite corner, but if there is a charge minus dq here, so there would be an exact opposite, you will also have this dq charge. So with respect to origin, all these charges are equally placed or symmetrically placed. So since origin acts as a point of symmetry, so therefore net dipole moment would also be zero. It will obviously be independent of origin, but it will also be zero. Okay, is that clear? So this is the information that was given in the exam. So I'm not writing much. Another question again was asked in GATE exam, and that's it said that if charge minus q is not symmetrically, is uniformly distributed on ellipsoid. So I'm not going into the ellipsoid thing because it was not given in the exam. Like it was no parameters was given to us in exam. It was just given this. So this is the information that was given to us. If charge minus q is uniformly distributed on an ellipsoid and q is placed at origin, then what all things can be concluded? One thing that can be concluded is that p vector would become independent of origin. That is, the net dipole moment would be independent of origin. And another thing that one can conclude is, because since charge minus q is symmetrically placed with respect to origin, one thing can be concluded that the net dipole moment would be equal to null vector. Is that clear? Now let us move to another question that was asked in NET exam, and it said that if these are the representation of the electric lines of forces, so if these are the representation of electric lines of forces, if these are the representation of electric lines of forces, how do you think your potential would behave at far away distance? So how do you think your potential as a function of r would depend? So if I say that potential is inversely proportional to 1 upon r ki power n, what do you think your n should be? Okay, so this particular thing was asked in NET exam. Obviously, this is slightly tricky. So let me just so what one can do in exam or otherwise, what you can do is probably you can place one charge here. Let's say I'll place Q here. So Q is a positive charge. So from standard 12th also you know that electric lines of forces always emanate from a positive charge. So let us make all these things, and I'm making this charge. So like emanate, they emanate from the positive charge. Okay. And obviously, if this is source, that is, if this is Q, this should be sink. Why this should be sink? Because these lines of forces are entering into it. So is that clear to you? And you can see that there are 4 lines emanating from this charge field, and there are 4 lines into it. So obviously these two charges will have the same magnitude. Okay, so the magnitude of charge depend upon the total lines of forces entering or exiting. I mean, this is something that we know from the standard 12, so I'm not going to write it all over again. And if this is minus Q, so obviously because these lines of forces should be entering into it, so I'll write entering, so like this. So there would be, this charge should be plus Q, and exiting, again exiting. And this Q is there, so there these lines of forces, so ये 3 दिख रही है यहाँ पर, अरे यार थोड़ा गलत बन गया. This should be leaving from plus Q, and this should be minus Q somehow. I hope it is clear now. Okay, yes, is that clear? So this this kind of arrangement, you can associate it to a square quadrupole. So this is the square quadrupole. This is a square quadrupole. What is a square quadrupole? Here you'll find that there are this is a positive charge, this is a negative charge, this is again a positive charge, this is again negative charge. So there are two opposing dipoles here. So this is the opposing dipole, this is also opposing dipole, this is also opposing dipole, and this is like there are two sets of opposing dipoles, and these opposing dipoles would get cancelled. So obviously this forms this forms a square quadrupole, and I've taught you in multiple expansion that for quadrupole your potential varies as 1 upon r cube. Is that clear? We'll study this thing in detail later on, but right now just understand that this forms a square quadrupole. Is that clear? Okay. Now another question, the same pattern was asked in net exam, that if this happens to be the case, that if this is plus q, this is minus q, this is plus q, and this is minus q, and let's say this is a, and let's say I'm talking of a distance r, which is way too greater than a, then what do you think should be the ratio of VR upon V2R? So one can clearly see that this is a square quadrupole arrangement, or you can say simply a quadrupole arrangement. So, and I know that in quadrupole arrangement, the potential is inversely proportional to R cube. So I'll write K upon R cube, sorry, R capital. Okay. So this will be K upon 8 R cube. So it will, answer should be 8. Is that clear? Is that clear or not clear?
Yes, sir.
Okay, good enough. So now another question that was asked in GIST exam. Let's say it says that two positive charges of magnitude Q separated by D, separated by a distance D, separated by a distance T, surrounded by a spherical shell. Surrounded by a spherical shell of radius 2D. Of radius 2D. And that is bearing a total charge minus Q. Bearing total charge minus Q. And this shell is centered at midpoint between the two charges, between the two positive charges. So what does it say? Positive charges Q. Then potential as a function of R is dependent upon R ki power n. Then what is the value of n? So obviously this was not asked. I'm just giving you an idea of what actually was asked. So what does it say? It says that there's a sphere which contains a total charge of minus 2q. Okay. And the radius is given to be equal to 2d. So this total, like this distance is 2d. And its center is at the midpoint of the two charges which were separated by a distance d. So this would be d by 2, this would be d by 2. Is that clear? Yes or no?
Yes, sir.
Okay. This minus 2q, I think I've written it incorrectly, bearing the total charge minus 2q uniformly distributed. And even if it was not uniformly distributed, if it is uniformly distributed, then from the origin, this minus 2q placement, like total minus 2q will be obviously some dq, 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 dq. So all these, you can say that origin is a point of symmetry for all these charges. That is on this surface, the total charges is minus 2q. So all these charges are placed, all these dq charges are placed symmetrically from origin, isn't it? मानते हैं यहाँ तक कोई दिक्कत? And these two charges are also symmetrically placed from origin. So you can say that your dipole moment should be zero, and your total charges are obviously zero. Your total charges are obviously zero, and your dipole moment is also zero, isn't it? Yes or no?
Yes, sir.
Okay. Then the leading term would correspond to the quadrupole moment. The leading term would correspond to the. Now there is a discrepancy here. The information given to us was not that sufficient that we can find like quadrupole moment here. The leading term would be corresponding to V quadrupole, and that would be that. In that way, I'll write that V as a function of R should be inversely proportional to R cube. So I would need some additional information, probably. Let's say if I just go back and see the question. So I think this was the question asked in just example, if I'm not wrong. एक मिनट check और कर लें दो. I think 2020. So 2017, if you see the options, so if you see the options were 1 upon R, 1 upon R cube, D, and 0. So if the options are not suggesting 1 upon R की power 4 dependence, then you should not go beyond it. So basically what they wanted you to check was just that your total P vector is 0 and total charges are 0. So the leading term would be given by V quadrupole. Is that clear or not clear?
Yes, sir.
Otherwise we'll have to solve it with completeness. मतलब इसको फिर proper solve करना पड़ेगा. Again we'll have to take a charge R, and then this would be not easy question for that matter. Because exam wise it would not be easy, and I've also not solved it in that sense. Okay, so this was asked in just exam. तो थोड़ा सा ध्यान रखना, exam wise बोल रहा हूँ. अगर exam में तुम्हारे पास options ऐसे हो जो कि quadrupole पे जाके end हो रहे हो, तो बस ये देख लो कि dipole moment और net charge zero हो रहा है कि नहीं. अगर net charge zero हो रहा है तो monopole moment zero हो गया. डायपोल मोमेंट अगर कहीं पर भी तुम्हें सिमेट्री दिख जाए, मतलब जो चार्ज की प्लेसमेंट है, इफ इट इज सिमेट्रिक विद रिस्पेक्ट टू ओरिजिन, क्योंकि देखो अगर टोटल चार्ज जीरो हो गया, देन यू कैन कन्वीनियंटली चूज योर ओरिजिन. सो यू कैन कन्वीनियंटली चूज योर ओरिजिन. हालांकि यहाँ तो ओरिजिन दे रखा था, यू कैन कन्वीनियंटली चूज योर ओरिजिन, एंड इफ विद रिस्पेक्ट टू दैट ओरिजिन योर पी वेक्टर इज जीरो, देन द लीडिंग टर्म वुड बी क्वाड्रुपल मोमेंट. और फिर तुम ऑप्शंस चेक कर लेना. अगर ऑप्शंस में कहीं पर भी 1 upon r की पावर 4 नहीं है, तो फिर तुम बहुत ज्यादा आगे तक जाने की जरूरत नहीं है. आई थिंक लाइक जो तुमसे पूछा जा रहा है एग्जाम में, इट इज बेसिकली चेकिंग दैट इफ यू आर एबल टू फाइंड दीज टू कांसेप्ट्स. तब जो मेरी समझ कर रही है, आई थिंक otherwise they would give you some hint. I mean, they would give you some hint. Or I'll solve this question in entirety also. Just give me a day or so. So I'll solve this question in entirety. But overall, this is the hint. Is that clear? Because to solve it, I will have to take a distance r from origin, और फिर इसका जो डिस्टेंस है उसको a लेना पड़ेगा. तो ये जो छोटे छोटे चार्जेस यहाँ सिग्मा ds लिखना पड़ेगा मुझे, और ये सिग्मा ds जो है वो r माइनस a डिस्टेंस दूर हो गए, और ये दोनों चार्जेस फिर ये d/2 होगा, ये d/2 होगा. मतलब इट विल बी अ वेरी लॉन्ग कैलकुलेशन, what I feel. So then I will have to do it in entirety. But right now इतना समझो, ठीक है? इतना समझ लिए. ये इस तरीके से what I want to convey from this lecture is कि किस तरह के क्वेश्चन एग्जाम में पूछे जाते हैं. So are you getting my point? So this is the level of exam. So हम लोगों ने कितना डिफिकल्ट पढ़ा है, और उससे तो बहुत इजी एग्जाम्पल्स. ठीक है, तो एग्जाम में इतना डिफिकल्ट नहीं है जितना डिफिकल्ट हम पढ़ रहे हैं. बट स्टिल आई विल सॉल्व ऑल दीज क्वेश्चंस, लाइक जिसमें सॉल्यूशन दे सकते. देखो यहाँ सॉल्यूशन नहीं दे सकते आप, बिकॉज हियर इटसेल्फ द क्वेश्चन इज सॉर्ट ऑफ इनकम्प्लीट, और सॉर्ट ऑफ थोड़ा सा एब्स्ट्रैक्ट है, जहां तुमसे पूछा जा रहा है कि तुम थोड़ा खुद ही सोच लो कि हाँ यहाँ क्यों होगा और यहाँ माइनस क्यों रहा होगा. बिकॉज देयर वर, आई एम टेलिंग यू, दिस क्वेश्चन केम इन माय एग्जाम ओनली, लाइक व्हेन आई वाज इन थर्ड सेमेस्टर इट केम, एंड देयर वाज नो सच साइंस गिवन टू अस. मतलब इसमें कहीं पर भी कोई डायरेक्शन नहीं दे रखी थी. सो ये थोड़ा सा मतलब थोड़ा सोचने वाला ही क्वेश्चन था somehow. And even this question was asked when I gave the GATE exam. So I gave the GATE exam in 2015. So point is this: there was no such thing given कि ये A B नहीं दे रखा था. It was just these two figures that were given to us. So मतलब समझ लो, they were sort of abstract only. They just want to know that you have an idea or not. बस. So थोड़ा सा एग्जाम में कभी-कभी एग्जाम की तरीके से भी चलना पड़ता. So like, are you getting my point? तो जैसे फॉर एग्जांपल ये हो गया, अब यहाँ साफ दिख रहा है कि दिस इज अ क्वाड्रुपोल अरेंजमेंट, सो ठीक है, ये ओवरऑल ठीक है. This question, I feel I will do it in the next lecture probably, the complete derivation part. I'll try to do it. But overall, till as much as options are there, you can conveniently say that your potential would be inversely proportional to RQ. Is that clear to you?
Yes, sir.
चलो जी, एक क्वेश्चन करके बताओ फटाफट. Okay, so I think we are heading to the ending to the heading to the end of the lecture. चलो ठीक है, एक काम करते हैं, एक स्क्वायर क्वाड्रुपोल और लेट अस डू द केस ऑफ स्क्वायर क्वाड्रुपोल. फिर एक क्वेश्चन और करेंगे एंड देन वी एंड दिस लेक्चर. So what is a square quadrupole? Square quadrupole, you can see it is equivalent to writing this kind of arrangement. तो इसको मैं थोड़ा सा चेंज कर दूंगा, this kind of arrangement. तो ये अरेंजमेंट हो गया जैसे q, यहाँ पे आएगा माइनस q, यहाँ पे आ जाएगा q और यहाँ पे क्या आएगा माइनस q. इज दैट क्लियर? अगर इसको तुम xy प्लेन में प्लेस करते हो और तुम z एक्सिस के अलोंग पोटेंशियल निकालने की कोशिश करोगे तो तुम्हारा पोटेंशियल आ जाएगा 0. करके देख लेना, यहाँ पे ओरिजिन ले लो और एक z एक्सिस के अबाउट अगर लोगे तो ये डिस्टेंस, लेट्स से दिस इज योर, इसको मान लेते हैं d, तो ये क्या हो जाता है, d बाय रूट 2 हो जाता है. ये तो पढ़ा होगा, ये डिस्टेंस रूट 2 d हो जाएगी तो आधी d बाय रूट 2 हो जाएगी. दिस विल बी लाइक, अगर इसको ओरिजिन मान लोगे तो दिस विल बी d बाय रूट 2 कॉमा d बाय रूट 2 कॉमा 0. और अगर तुम किसी पॉइंट z पे निकालने की कोशिश करोगे तो you'll find that your potential will come out as 0. ये करके देख लेना. आई थिंक दिस इज क्वाइट इजी टू सी. आई एम नॉट डूइंग इट. ठीक है, ये मतलब करस्पॉन्डिंगली तुम लिखोगे ना तो तुम्हें अपना आइडिया लग जाएगा मैं क्या बोलूं. सो इफ यू वांट टू फाइंड द पोटेंशियल along the z axis, you will find that this potential would be 0. Is that clear or not clear? मतलब ये तुम करके देख लेना. This is something I'm leaving it to you. So one can see that potential will be along the plane. So plane के along potential होगा. तो इस प्रॉब्लम को थोड़ा सा चेंज कर देते हैं. Let us change this problem to this. Let us तुम समझ पा रहे हो मैं क्या बोलने की कोशिश कर रहा हूँ? देखो, अगर तुम पोटेंशियल निकालने की कोशिश करोगे ना तो पोटेंशियल क्या होता है, पोटेंशियल इज के क्यू अपॉन आर. सो इंस्टेड ऑफ आर, क्योंकि ओरिजिन ये रहा, तो यहां से यहां तक का डिस्टेंस क्या हो जाएगा, डी बाय रूट टू आई कैप डी बाय रूट टू जे कैप 0 के कैप. और ये डिस्टेंस क्या हो जाएगा, ये जो दिख रहा है ये मतलब ऊपर की तरफ है. आर यू गेटिंग माय पॉइंट? दिस इज जेड के कैप. तो ये हो जाएगा, दिस पॉइंट वुड बी गिवन बाय 0, 0, जेड. तो ये जो कोऑर्डिनेट है दिख रहा है, ये जो लाइन है ये क्या हो जाएगी, इट विल बी सिंपली, आई एम राइटिंग हियर, इट विल बी डी बाय रूट टू माइनस 0, डी बाय रूट टू माइनस 0, 0 माइनस जेड, दिस इज माइनस. ऐसे करके सारे डिस्टेंसेस निकालोगे ना तो तुम्हें रियलाइज होगा कि ये जो पोटेंशियल है इस पॉइंट पे, इट विल कम आउट एज 0. करके देखना, अगर नहीं है तो बताना.
सर सारे डिस्टेंस तो वैसे भी इक्वल होंगे ना, के क्यू
सारे
आर
डिस्टेंस
से
क्योंकि
टोटल
इक्वल होंगे,
क्यू
क्योंकि
क्यू और
डी स्क्वायर और जेड स्क्वायर हो जाएगा. यहाँ पर भी डी स्क्वायर बाय 2 प्लस डी स्क्वायर बाय 2 प्लस जेड स्क्वायर. यहाँ पर भी डिस्टेंस क्या हो जाएगा, डी स्क्वायर बाय
यस
2
सर
डी स्क्वायर
जीरो
बाय
जीरो हो जाएगा.
प्लस जेड स्क्वायर. यहाँ पर भी सेम हो जाएगा. एक माइनस क्यू है, एक माइनस क्यू, एक प्लस क्यू और एक प्लस क्यू. along z axis you will find that your potential will come out as 0. समझ पा रहे हो मैं क्या कहने की कोशिश कर रहा हूँ?
यस सर.
ठीक है, लेकिन तुम देखोगे कि अगर इलेक्ट्रिक फील्ड से मैं इसको निकालूंगा कि अगर मैं ऑन द प्लेन लूं तो देयर इज अ पॉसिबिलिटी ऑफ हैविंग पोटेंशियल. तो देखते हैं, लेट अस सॉल्व दिस प्रॉब्लम, लेट अस सॉल्व दिस प्रॉब्लम फॉर फाइंडिंग इलेक्ट्रिक फील्ड. तो एक लेवल ऊपर जाते हैं, लेट अस फाइंड इलेक्ट्रिक फील्ड फॉर द सेम कॉन्फ़िगरेशन. थोड़ा सा चेंज कर देते हैं जिससे कि थोड़ा इजी हो जाए प्रॉब्लम. लेट अस फाइंड द इलेक्ट्रिक फील्ड फॉर द फॉलोइंग कॉन्फ़िगरेशन. फॉर द फॉलोइंग कॉन्फ़िगरेशन. तो मैं क्या करता हूँ, मैं थोड़ा इसको स्क्वायर को थोड़ा काजू कतली बना देता हूँ. तो समझ पा रहे हो, मतलब मैं ऐसा करूंगा, ये दो दो चार्जेस है ना, ये तुम्हें ऐसे दिख जाए. अरे यार, जस्ट गिव मी अ मिनट. ऐसे, ऐसे, और ये साफ दिख रहा है कि अगर एक चार्ज प्लस क्यू है तो उसके ऑपोजिट भी क्या आएगा, प्लस क्यू ही आएगा. तो लेट्स से इसको थोड़ा नीचे ले जाते हैं जिससे कि तुम्हें समझ में आ जाए. ठीक है, अरे यार, चलो जैसा भी, ठीक है. सो लेट्स से ये वाला चार्ज है माइनस क्यू. आई एम राइटिंग इट एज माइनस क्यू. ये चार्ज मान लेते माइनस क्यू, और ये वाले चार्जेस क्या मान लेते क्यू क्यू. ठीक है, ये भी क्वाड्रुपोल ही होगा, कोई दिक्कत तो नहीं. ये सिर्फ मैंने थोड़ा सा दिखाने के हिसाब से, और मान लेते हैं ये ओरिजिन एंड वी आर टॉकिंग ऑफ on the plane. We are talking on the plane. We are not talking perpendicular to plane. We are talking on the plane. Is that clear? और मान लेते हैं we want to find the potential at a distance r from the origin. We want to find the potential. Potential की बजाय काम करो पहले इलेक्ट्रिक फील्ड पता कर लेते हैं, और इलेक्ट्रिक फील्ड अगर पता है then we can find the dependence of potential as well. ठीक है? So let us say ये डिस्टेंस यहाँ से यहाँ तक, एक काम करते हैं थोड़ा सा और भी, इसकी डिस्टेंस मान लेते हैं l, इसकी डिस्टेंस मान लेते हैं l, तो ये डिस्टेंस यहाँ से यहाँ तक मान ली r है, ये डिस्टेंस क्या बेटा r मान लेते हैं, यहाँ से यहाँ तक डिस्टेंस क्या मान ली r वेक्टर. So I'm writing it here. This is r. ठीक है. So this is r. So this distance, ये छोटी सी डिस्टेंस दिख रही है यहाँ से यहाँ तक, ये डिस्टेंस कितनी हुई आइडिया दे सकते हो? This is let's say d and this I can write as l by root 2. कोई दिक्कत? बिकॉज देखो अगर ये l है तो ये डायगोनल डिस्टेंस क्या होती है, √2l, और इसका आधा l by √2. इज दैट क्लियर? हाँ या ना तो बोलो फटाफट से, नहीं तो फिर वही दिक्कत आएगी, थोड़ा तो लेक्चर एंड हो जाएगा इसलिए करो. ठीक है, तो ये इनके डिस्टेंसेस ऐसे लिखे और इसके डिस्टेंस. मैं परपेंडिकुलर प्लेन पे इंटरेस्टेड नहीं हूँ, मैं ऑन द प्लेन एंड सेम. ठीक है, और ये डिस्टेंस आर है, तो ये डिस्टेंस मान ली डी है, और ये डिस्टेंस मान ली डी को मैंने लिख दिया ऑलरेडी l by √2. इज दैट क्लियर? नाउ लेट अस ट्राई टू, अच्छा बाय सिमेट्री वन कैन अंडरस्टैंड, अगर ये थीटा तो नेट इलेक्ट्रिक फील्ड इस डायरेक्शन में आएगा. क्यों? क्योंकि देखो ये नेगेटिव चार्ज है. सो अगर यहाँ पे अगर मैं पॉजिटिव चार्ज रख रहा हूँ 1 कूलम पर, तो इट विल अट्रैक्ट इट हियर, it will attract it here. So the net electric field will be in this radial direction. So I'll write by symmetry, net electric field will be in the radial direction. ठीक है? Is that clear बेटा? So overall net electric field निकालते हैं, और एक बार इलेक्ट्रिक फील्ड की डिपेंडेंस पता लगे तो पोटेंशियल पता करने में बिग डील नहीं. ठीक है, तो इलेक्ट्रिक फील्ड एज अ फंक्शन ऑफ आर क्या आएगा, सोचो, मैं आर लिख दे रहा हूँ, हो जाएगा के क्यू अपॉन आर माइनस डी का होल स्क्वायर. मानते हो? देखो दिस यहां से यहां तक की डिस्टेंस कितनी, यहां से ओरिजिन ये रहा, यहां से ओरिजिन की डिस्टेंस कितनी आर, सॉरी ओरिजिन से ये डिस्टेंस कितनी आर. सो फ्रॉम ओरिजिन, like from origin this distance is r and this is d. So this will be k q r minus d का होल स्क्वायर आउटसाइड. समझ पा रहे हो ये बात समझ पा रहे हो नहीं समझ पा रहे हो? Because of this the electric field will be plus kq upon r plus d का होल स्क्वायर and then minus 2kq upon, इसको कुछ ले लेते हैं, let's say r1, so हो जाएगा minus 2kq r1 का स्क्वायर and this will be cos theta. Is that clear or not clear? हाँ या ना, फटाफट से बोलो.
हाँ मैम.
गुड इनफ. सो अगर ये d है तो ये भी d होगा, मानते हो? अगर ये d है ये भी d ही होगा बेटा. अगर ये d है तो ये भी तो d ही होगा, l by √2.
Yes,
हाँ
sir.
भैया.
And this is r. यहाँ से यहाँ तक पूरा दिख रहा है ये r. So can I not write that my r1 square is nothing but r square plus d square? And if that is the case, and if we take a very far away case, that is if we want to take a very far away case, then we can use binomial expansion. Is that clear? We can use the binomial expansion. Is that clear? So what I'll do, and cos theta I will write, cos theta I can also write it as r upon root over d square plus r square. So overall this last term, so electric field as a function of r, I can write it as kq upon r minus d ka whole square, then I will write plus kq upon r plus d ka whole square, then I will write minus 2kq upon r plus d square की पावर 3/2, और एक r और आ जाएगा, एक r आएगा, क्या आएगा, और आएगा. Is that clear or not clear? यहाँ तक समझ में आए? अब binomial expansion लगाने के लिए what you can take r common from each one of them, and obviously this direction I'm taking as increasing direction of r, so I'll write this direction as r cap and this direction as minus r cap. तो वही मैंने किया है, यहाँ नेगेटिव लिया है और ये दोनों उस डायरेक्शन. So I'm just indicating that this is the field direction. अब देखते हैं पॉजिटिव आता नेगेटिव आता, that is to be seen. तो एक kq upon r square कॉमन ले लिया, and this will be 1 minus, let's say epsilon लिख दिया का होल स्क्वायर, 1 plus epsilon whole square, and this r is there, this r square अगर common लोगे तो r cube आएगा, this will be 1 plus epsilon square की power 3 by 2, where epsilon is what? It is equals to d upon r. Is that clear? Is
Yes,
that
sir.
clear? Okay. So overall you will find, मतलब हमें से डिपेंडेंस पता करनी थी. कल मैं ये कह रहा था कि वंस एक बार एक तुम्हें मैं आइडिया दे दूंगा कि इस क्वाड्रुपोल की डिपेंडेंस कैसे आती है. देखिए स्क्वायर क्वाड्रुपोल ही है. So you will find that this will be 1 minus 2 epsilon plus 2 into ये कितना है ना, ये क्या लिखूंगा मैं, 1 plus x की पावर n into n plus 1 by 2 factorial, right? n into n plus 1 by I think 2 factorial. क्या होता है? 1 plus x की पावर n is equivalent to 1 plus nx plus n into n minus 1 divided by 2. Oh, sorry, this is minus 2. This is minus 2 and this is minus 3. I'm sorry. So this will be 1 plus 2 epsilon. ठीक है ना, ये minus 2 होगा. So this will be minus 2 into minus 2. That is minus 2 into minus 3. And then there will be epsilon का square. So I'll write simply 3 epsilon का square. Is that clear? और कुछ आगे के टर्म्स होंगे, I'm not interested. Plus 1 minus 2 epsilon plus 3 epsilon square मानते हो? आगे के टर्म्स में I'm not interested. And then again 1 minus of, I think it will be 3 by there would be 2 is also there. 2 is here, so 2 will be here, and this will be minus 3 by 2 epsilon ka square. I'm not interested in higher terms. So electric field will be radially outwards with the leading term. So I'm just interested in the leading term. So I'm just interested in the leading term of the electric field as a function of r, and obviously this will be in this direction. Let's see what is the answer. This will be kq upon r square, and you can see this 2 epsilon and 2 epsilon get cancelled. So I'm not writing that. So this is I don't know where I've got wrong. So देखते हैं एक बार. This is 2 plus 6 epsilon square, and then it will be plus. This is plus, nahi, this is minus. I'm so sorry. This is minus. This will be minus 2 plus 3 epsilon square. So there would be a additional bracket. I'm not interested. I'm just interested in the leading term. Okay. So I'm just interested in the leading term. So E leading term of the electric field, which is radially outwards. And this will give you an answer that it is kq upon r square. And I think there is some 6 plus 3. This would be 9. And what is epsilon? Epsilon is d by r. So epsilon square will be d square upon r square. And there would be obviously some terms I'm not interested in. I'm only interested in leading term. So the leading term of the electric field for this square quadrupole kind of arrangement in the plane is given by kq d square upon r cube power 4. So your potential would obviously be dependent upon r cube. Is that clear or not clear? So याद रखना, आप इसको याद कर लेना कि whenever you have this opposing kind of situation, जहां पे opposing dipoles दिख जाए तुमको, always remember that your potential will be inversely proportional to 1 upon r cube. Because electric field एक बार मिल गया तो infinite से r तक ले जाना, integrate कर देना. I think you will be able to get, because I hardly have some time left. So, okay, is that clear or not clear?
Yes,
Hello,
sir.
is that clear or not clear? ये समझ में आया, ऊपर से चला गया?
Yeah.
Okay, good enough. So एक काम करो, एक homework ले लो, and we'll start this question tomorrow. अब इसके बाद मैं नहीं ले सकता because तुम भी मर जाओगे, मैं भी मर जाऊंगा. So in a thin insulating rod, the same question that we were doing, running from minus a to plus a, running from z equal to minus a to z equal to a, carrying a linear charge density lambda is equals to k cos pi z upon a, where k is a positive constant. Find the leading term in the multipole expansion of the potential. Find the leading term in the multipole expansion.
ये तो अभी किया था हमने.
हाँ, ये नहीं किया था, ये नहीं
साइन
किया
होगा
था,
शायद.
साइन किया था, ठीक है. मल्टीपल एक्सपेंशन ऑफ पोटेंशियल. try to do this problem and we'll meet tomorrow.
सर ये वाला वीडियो शेयर कर दीजिएगा।
हाँ बिल्कुल बिल्कुल।
थैंक यू।
ओके, थैंक यू सो मच।